I will continue. So we started with traversing the commit tree yesterday. What we did is investigate the commit tree with git log. We compared commits with git diff, and also used git checkout to get the two-way commit ordering time. And then I will just remind you that when we do a git checkout, we only move, so let's say we are in this situation here. We have head pointing to the latest commit, which is the tip of this master branch. When we do a git checkout to, let's assume commit B here, we only move the head reference if we are on the same branch. And we'll see later today how we can actually switch to different branches with git checkout. But we can also go back to commits by using the git reset command, but it does behave quite differently. The options are, well, the way to use it is git reset with some options that you can use. I'll explain what these are. And again, with a reference, which can be a hashed commit or other reference that we learn about. What is important is to decide, depending on what you want to do, is which option to use together with git reset. Now, if you use the so-called option soft, then the only thing that is changed is the reference to head. So head is going to be moved to the reference that you specify together with git reset. But git reset will try to preserve what you have staged, so the index, and then it's also going to try to preserve the working tree or working directory or workspace as it's called sometimes. So it will try to have the changes in your working directory as it was before the git reset. If it cannot, then you are going to get I'm trying to think if it's going to give you a warning. Now, if you use the mixed option, which is the default one, then what git reset, what git is going to do is not only to update the head reference to the reference that you have specified, but it's going to also unstage what you had staged before git reset. Or what has been staged at the moment when you do git reset. But again, it will try to keep the modifications that you have in your working tree or working directory. Now, the most extreme option is the hard option, and that is going to update both the head, is going to stage all files, and then also remove all modifications that you have in your working tree. And then it's going to get you to a stage of your working repository as it has been at the time of these commits specified by ref. So this is most extreme, and it's particularly useful if you realize, oh, I have really messed up my working tree and I just want to reset everything to what has been before. And I should also mention that it is possible to use head as a reference as well. And then what that will actually do is just to clean up your index and working tree or working directory. Okay. So then one important difference with git checkout is that when you do git reset to another commit reference, it will not only move the head, but it will actually also move the reference, the branch reference, which is associated with the head at that point. So if the head has been pointing only at a commit, which is not the tip of the branch, so let's assume this commit B, then when you do git reset to commit A, for example, the head reference is going to be moved to this commit. Now, if you are in the situation when you're at the tip of the branch, when you do git reset, so both the head and the master is pointing to this commit C. When you do git reset to, let's assume, commit A, not only the head reference is going to be moved, but also the branch reference. So master will also be pointing to this commit A. So then what happens actually with these two commits that you had? So that simply means that they will not be associated to a branch. They will just be commits that you can only access by their commit hash and only referenced from the git ref log and not the log, because remember, the log is only going to specify everything from a certain commit and all its ancestors. So if you have used git reset by mistake, then you can revert discarded commits by accessing the ref log. And we will see how we can do that later today. So remember that we can also use git checkout and git reset to actually deal with changes in our working directory and stage the modifications that we have done. So it can have git checkout and reset applied to files as arguments, and then it means, well, in the case of git checkout with a file as an argument, then what this will do is going to discard all unstaged changes. So it will keep the index or the staging area, but it will just clean up the working tree or working directory. Now, if we want to unstage the modifications, so clean up the index, then we use git reset. So this, and with the file as argument. So this will unstage the file, but it will keep the modifications in the working directory for this file name. So then this is just an example. We can quickly go through this. So then let's assume that I am modifying a file txt. So what this echo command does is just to add an additional line to the file txt. So then file txt is going to be modified, but we have not yet staged these modifications. We do stage the modifications to the file txt with the command git add. Now, so now I have both these modifications in the working directory, and I also have staged these modifications. And I can check what are my staged changes in the directory with this git diff cached, and that is going to show that, okay, I have this additional line, even more content in the file txt. Now, using git reset and the file name, I can unstage the changes. So those are not going to be staged anymore. And this is also what git diff cached shows. So I have no staged changes, and I can and then I can actually compare, okay, which modifications I have in my working directory compared to the index, and then I get the output even more content. So that this simply means that I have unstaged modifications in my working directory because I have unstaged this file. So the modifications are kept there, but they are not indexed. So they are not in the staging area. If I want to remove these modifications, discard these modifications from the working directory, I can do that with git checkout and the file as argument. Sorry, it really wants me to update. That's a very bad time. Okay, so with git checkout file, I can discard the modifications, and this is what this line actually means. So whenever you see updated path from the index, it just means that the working directory has been modified. In this case, we reverted these modifications in the file txt. And then git diff, it's going to show that my working directory is just the same as the index. I mean, I simply do not have any modifications that are staged. Okay, so, but because git checkout can be used both with hashes as arguments, it can also be used with files as arguments, then it can actually be confusing as a user of Git. So what the Git developers have introduced is another command that can be used for unstaging and disregarding modifications in the working tree that only works with files, and that is the git restore command. And it has been a while since version 2.23, which is quite old nowadays. But if in case you do have a version older than that, then you may not be able to use it. But I think that's fairly unlikely nowadays. What would I recommend? I would say, I mean, use the one you are used to. If you do not if you do not have a preferred command, then I would personally go for git restore. I think it's very clear. And then, well, you know that you are not in the danger of changing your head in any way if you use git restore. Another comment to add here is that in case you do not remember any of these commands, use git status a lot, because that will always show you what is the state of your working directory, or any changes that you have made in your working directory, any changes that you may or may not have staged. And it will also suggest you how to unstage file or how to discard changes in your directory. So as a beginner, I would say use git status, well, all the time. Before you commit, before you do git checkout, before you do git reset, always make sure what is the status of your directory. Okay, tagging. Rita mentioned a little bit how to create tags. So the simple way of doing actually, before I show you how to create a tag, I will tell you how you can list all the tags, and that is by using the command git tag. So this will list all the tags that that have been specified for different commits. So when is actually tagging useful? So let's assume that you do want to refer to a commit, a special commit that you have released to not code developers, but maybe people that are using your code, but they are not actually interested so much in the development of the code. They just want to run it. Then it is useful to specify, to refer to a certain version of your repository, or a certain state, sorry, of your repository by either a version or some other tag. And you can create a tag by using the git tag command, then the name of the tag that you want to give, and then the commit hash, which is associated with the commit that you want to tag. If you use the git tag command in this way, then what you do is create a so-called lightweight tag. So the only thing that the lightweight tag does is to again associate another reference to the commit, and that reference is going to be the tag name. This is not very useful if you work in a shared repository with many other developers, because they may not know, okay, so why did you use this certain version? What is this commit? How is this commit special in any way? Then what you should do is to create a so-called annotated tag. And the nice thing about this is that not only you can give commit a tag, but you can also write a comment, like why you have chosen to tag this particular commit, and yeah, any other comments that you may wish to add. And annotated tags are going to, well, update the references with this tag, but it will also store the information on the person who has created this tag, and also the creation time and the comment. So it's a little bit like a commit in that sense, but with information, as I said, on the tag creator and the time of this tag addition. Now, how can we refer to different commits? Up to now, we have referred to them a lot by means of a commit hash, but we can also use references in, and those can be, well, the head, or it can be the branch names, or you can even use these long names that you find in the hidden Git repository. So if you go to .git/refs, then you can see all the references that have been modified, and the content of those different files will be the hash, the commit hash that the reference is pointing to. Okay, we can also refer to ancestors of commits by using head tilde, for example. So this is going to show us the parent of a commit, or head double tilde is going to give us a so-called grandparent of the commit. And similarly, the ancestor can be referred to as reference and then tilde n, which yeah, I mean, I think referring to ancestor which is well, let's say up to 5 is still fine by using this, but if you have a really old commit, like, I don't know, 100th commit back in time, then I think it is still best to refer to it by using the hash, so that you know that you're not making any mistake. But for parents and grandparents, I think it's very useful to just use the tildes. Okay, now in case of merged commits, so commits that have two parents, then you can refer to either of the parents. So the first parent using the head 1, and then the second parent head 2. And generally, you can actually refer to a nth parent by using reference and then head n. And then the question is, okay, but when do I actually get more than 2 parents for a commit? Okay, that is very special in the case when you do branch, merge many different branches, and that's so-called an octopus merge. It's not something we will cover, but it is a situation that can occur. So in general, yes, you may refer to these parents this way. Okay. So then how can we clean the working tree? So we did show how to discard changes that have been made to the files. So discard all unstaged changes by using either git checkout with the argument file name, or we can use git restore with the argument file name. So both these commands do the same thing, and that is to discard unstaged changes. Now I may also unstage the files, so clean up the index or the staging area by using git reset, followed by file name as the argument, or the option git restore, or the command git restore with the option staged, and then followed by the file name as argument. So then this is just a recap of git reset. I'll skip this as we have not done it so long ago. So then these commands are all good if Git knows about them. So if these are tracked files. But what if a file is untracked? And when is a file untracked? Well, that is a file that has been modified in your working directory, but it has never been added to the index. So it does not have a corresponding blob yet. Git has no idea, oh, what is that file about? But you may still use Git in order to clean up these untracked files. And why is that useful? So why wouldn't one just do like a simple rem for so remove for cleaning the files? I think the reason for that is because you still don't want to remove some files by mistake. So remove files that are tracked by Git by mistake. So this is like a safety guard to ensure that you actually achieve what you want. So untracked files you can clean you can remove by using the git clean command, and there are several different options that you can use for that, and you may also use it with arguments, and those arguments, so this path can be either a file or several files, or it can be a directory. And the options, first of all, dry run is always great to use to ensure that you are going to clean what you actually want. So it's just going to list what would be clean, but it does not actually clean things. So it does not remove things. So cleaning in this context means removing changes in your working directory. You can clean files recursively with the -d option, -i if you want to clean them interactively. And you can also choose to clean ignored files as well. So what are ignored files? These are files that you specify in the .git ignore. In the .git ignore file, which is in the hidden Git directory, and they are so it's useful to specify ignored files, especially if they are like very large files which do not actually need to be tracked by Git, or there may be files which are a result of the compilation of your program and they are not really needed to be version controlled. So then you may want to introduce you might want to tell Git to ignore a certain type of files. And then if you only want, for example, to clean the ignored files, then you may use this option. So let's say that you do usually ignore completion files, but then you want to clean the directory from those files, then you can just use git clean -X and then path. But again, it's always good to ensure you do a dry run before you actually do the cleaning, so that you see which files will actually be cleaned. Okay. So any questions up to now? Okay, I'll take that as no. If what I forgot to say is if you find I'm going too fast, too slow, then write a comment and then I will take that in mind. Okay, then we will continue with stashing changes. So stashing is actually great when you are in the situation that, okay, you are working on your repository, you have made some changes in your working directory, possibly even staged some of those changes, but then you realize, oh, I actually need to do a commit which has nothing to do with these modifications. So let's say my colleague or your comes and says, oh, there is a bug in this file, you need to change it immediately, and you are not ready to commit these other changes that you have done to your directory. So one possibility is to stash them away, so to move them to a certain space that you may recover them from. This is also useful, so not only when you want to do new commits, but then also when you want to use git checkout or git reset to investigate some commit further back in time, because git cannot always restore the changes you have in your working tree. Then it's always a good idea to stash those away, and then you can do git check out the different commits and then investigate uh, the repository at that point in time, and then go back to your latest commit and continue your work. So let's give an example here. So let's assume that we are doing git checkout to go back to a commit some longer time, sorry, a commit which is older in time. And then also assume that you have some modifications in your working directory which have not been committed yet. So if you do attempt to do git checkout to a different commit, then you are going to get an error saying that your local changes, and that means what, the local changes in your working tree or working directory will be overwritten if you do a git checkout. In this particular case, it was a README file that has been modified locally, so in the working directory, but it also exists in this commit here. So then, I mean, Git has a problem in actually deciding, okay, which version of the README file to use. So then it will block this Git checkout. But Git is very useful in telling you what you should do in this situation. So then it gives you two options. One of the options is either to commit the changes that you have introduced. So in this case, there are some README empty changes, or also recommends you or suggests you to stash them away before you check out to a different commit. And let's assume that you actually are not ready to commit, because maybe whatever implementations that you need to do is not ready yet, so it does not make sense to make a commit yet. But then the option is to stash the changes. And the way you do that, so before you do the git checkout, so in a state where you have some modifications in your working tree, possibly some of them staged, then you do git stash followed by push. So git stash push, and I will just make a comment here that actually if you just do git stash without push, it is going to be the same as doing git stash push. This is again because Git is in development. Stash has not been around for that many years, so simply both of them work. But nowadays, it is recommended still that you do git stash push, because also it has many different options that you can use with push, and it will make things clearer. But this is just a note for those of you that have been using git stash before and might know that you don't always need to have git push. Okay, but then, so again, what git stash push does is going to save changes that you have in your working directory, and also changes that you have already staged in a stash so in a so-called stash, and by default it's going to save it with this stash message, which is work in progress, and then the branch name from which you have done git stash. And then it's going to also mention the commit. So where head was pointing to when you have done this git stash push, and then the commit message for that particular commit. Okay, so you do git stash push, then you save away the working directory and the staging area. So then what you have is going to be a clean working directory and a clean index by default. So it means that you will not have any modifications in your working tree anymore. So it will be the same as the state of the head commit. Now you can safely do git checkout to another commit, and because the working directory is clean and also by default the index, then git checkout is performed without any issues. Okay, but how can we actually refer to these stashes that we may have saved for our repository? So you can list all these different stash entries by using git stash together with the list option. And then this is going to list all these stashes from the most recent one to the oldest one. And then so it will have different indexes for the stashes. Always the latest one is going to have 0, and then older ones, increasing number as you have more and more. And then by default, again, the stash commit, the stash message is going to be work in progress, and then the branch that the stash has been made from. And then the commit message, the commit hash and commit message. It is possible to, so when you do a git stash push, it is possible to specify a different stash message with the option -m and then followed by the stash message. So that you may choose to do. Let's say you want to be very specific about what this stashing is all about. Okay, so we have seen how to list these different stashes, but let's say a week or two from now, we actually want to know, okay, but what have I actually saved in the stash? The way to do that is by using git stash show, and then as argument the index for the stash. And that can be either this number here, or you can use this whole argument here. But if you only specify the number, so the index, then Git knows, as you're using git stash, Git knows that you refer to this stash, that reference. by only specifying show and then the index, you just get a list of the files that have been modified. In this particular case, it was just a README file that has been modified. But if you actually want to see more information about the file, then you can add this additional option, -p. Okay, so let's assume that I am now ready to continue my work that I have started with before stashing away these changes. So I go back to whatever latest commit on the master branch, and then I want to retrieve the changes that I have stashed away. I can do that by using git stash followed by pop. So then what that will do is going to change the working directory to match the modifications that I have stashed away, and it will also stage the files as they have been staged before I have done the stashing. If yes, and one very important thing to remember is that if you use git stash pop, then the entry is going to be dropped. And what this means is that I am no longer going to have a stash entry that git saves. So this, for example, is going to be removed. So if you are unsure that you want to continue your work, then one possibility is just to apply the stash, but keep the files as a stash entry. So, and you may do that by git stash apply, and then the stash ID. So again, this is useful if you just want to remember, okay, what have I actually stashed away? Then you may just apply the stash, maybe do some work on those files and stash them away again if you really want to, and if you're not ready to commit. So git stash push can be used with this git index option as well. It's quite useful. So what this actually means is that it's only going to save the changes of the working, the unstaged changes in the working tree, but it's going to keep the index. So it's going to keep all the unstaged modifications as they are. And it's useful if, for example, is like, okay, you are ready to commit what you have staged, but you just want to stash away modifications that you have not staged yet. And we will have an exercise on this, and I think that will help out to grasp these different concepts. Okay, this is just a thought exercise. You can read about this later. So what we'll learn in the following, actually before we do that, any questions regarding stashing? Oh, sorry. Okay, then some really important concepts that we'll learn in the following is how to make changes to the commit tree. We have seen a bit of that by using the git reset command, but we are going to learn some other commands that allow us to modify commits, modify the commit tree. In other words, modify the commit tree that we have for our repository. So just a quick reminder, if I am in a detached head mode, so, and again, what does detached head mode mean? It means that the head is pointing to a commit which is not the tip of the branch. So it's some commit, yeah, some commit on a branch, but not the latest one. So we simply do not have any branch reference associated with that particular commit. So if we are in that detached head mode, then git reset is going to move only the head reference to a commit that we specify. But if we are on the tip of the branch and then head also points to a branch reference, then when we do git reset, we are also going to move the tip of the branch. So simply discard commits from the master branch in this case. So this is useful if we want to discard a latest commit. Let's assume that we have made a mistake. So we can discard this mistake by using git reset head tilde, and that is going to simply move the head to the commit prior to the prior commit. So specified by this head tilde. So this is the prior commit. If I use git set without any options, it's going to default to this -- mixed, which means that it's going to keep the modifications that I have in the working tree. If maybe I decide to commit them later. But if we did the reset by mistake, that can happen. So we can still go back to the commit that we had before the reset, the commit that the head was pointing before the reset, and we can do that by specifying the hash that we had. As a note, if we also want to discard the changes that we have in the working tree or working directory, then the option to use is --hard. So this will unstage files and also disregard all changes in the working directory. And it's nice that we have questions in our Q&A document, and that is if we can always recover things from Git, or can commits be removed permanently. So you can always recover commits that you have on your local repository, and you can access them with the ref log. But now, what you should remember is that if the commits that you have discarded have not been pushed to some remote repository, so somewhere in the cloud or on GitHub or wherever, or on a different path on your computer, then those are not accessible to other people. So they are always. So the ref log is actually local to your repository, but it does not get pushed to other copies of your repository, at least not by default, and not that I know. So, but it's always available on your local repository, and you can recover these commits that you have discarded. Okay, how can we change the last commit? So let's assume that well, I have this linear branch. So I have this branch with these commits ABC, and I have made some modifications to my Python script. And but then I actually realized that I have not that I have done a mistake, for example, in this script, or I have written an incorrect commit message. It can be many different things. So what I actually want to do is to change the commit that I have done and add some more things to it, be it either some modifications to my Python script or some additions to the commit message. And I can solve this problem by adding the modifications that I have to my file txt or program.py. So stage those modifications, and then I can use the git commit with the git commit command with the option amend. So then what amend is going to do is going to remove this head commit. So it's going to remove this commit, but it's going to apply the changes that have been introduced by the commit and then create a combined commit from the index and the commit that was prior. So combined index and changes that have been introduced in C. And as a result, we are going to have a new commit, but it's going to have a new hash. And the reason for that is because, well, each hash is unique, and it's like a unique identifier for the content of the working tree, the creator, and the time. So if we change any of these, then the hash is going to be altered. So what in practice means that, okay, so I have all the changes that I wished to have in this new commit, but the history has been changed. So I'm not in the situation where I had the commits ABC, but I have AB and a new commit, so C star, which has a different hash and slightly modified version of the repository. So this is okay if you have. It's okay to do if you have worked. Well, if you just modify this commit C and you have not pushed your changes, so your changes are not shared with other collaborators. So your changes are still in your local repository. Then it's perfectly fine, and it's even nicer actually if you do git commit amend, because then the history of your repository looks nice and clean without any mistakes that you may have introduced in commit C. Now, if you have already shared your repository online with others, and we'll learn how to do that tomorrow, then that is dangerous, because then your collaborators will not have the same history of your commits as you have, and it will introduce different errors when or at least warnings when you are trying to sync those repositories. So word of caution is, do not do git amend if you have already pushed your changes, but it is perfectly fine to do it if you're working on your local repository. I'll move this away. Sorry, it really. Oh, no, that doesn't work. Okay. So what git amend actually does, git command amend actually does, is to reset the head. So it goes to the parent of the head commit, it's going to keep the index and the working directory. So this is what this soft option means. And then it's going to commit the changes that I have introduced, but by using this original head reference. So the reference that we had before. But actually, the only thing that you need to remember is that if I do a git commit amend on this particular commit, I can add some modifications to my working directory, stage them, and then just add those modifications to this particular commit, and then replace this commit with a new one. Okay. If let's assume that we have actually pushed these changes to some other remote, and we do not want to rewrite the history of this commit. So we want to keep this commit, even if it is a mistake. We want to keep it because we already pushed, and people have been using the repository, and yeah. Simply, we do not want to mess up with the commit history. Then the safe way to do that, so I mean to fix mistakes in our commits, is by using the git revert command. And then so let's assume that we have done some commit on our master branch. But then we discovered that the changes, or at least part of the changes that we introduced, contain a mistake, and we want to revert that mistake. So then what we can do is to use the git revert command with the argument the hash of the commit where the mistake has been introduced. So then git revert hash is going to then create a new commit, and then in the new commit is going to simply undo the changes that were introduced in this particular commit. The difference is, so if you compare this git graph here with the new one, then you see that I still have this bad commit that I have done. So that is in the history. It's perfectly safe in shared repositories, but I have a new commit that I have introduced, and it's simply reverted the changes that I had introduced in commit 46. So again, this is the best way to revert changes that you have introduced in your commits in a shared repository. If you only work locally, then git commit amend is still a valuable option, and the same with git reset. Okay. So then it's actually time for exercises. But before we do the exercises, then I think that we need a break. So we can take a break for, let's say, what did we say in the schedule? I'm going to check. So we can take a break for 15 minutes. And then we can come back and then continue with the exercises. And we are not recording exercises, so then at any point you are actually free to ask many different questions. And then we can also open up the breakout rooms so that you can work together if you wish. And where do you find the exercises? I should say, in case some want to start earlier, but do take a break. So you find everything in exercises, and then traversing the commit tree. So if you have already cloned the repository, you don't need to reclone it. You still, I mean, you have all the exercises that you need. So it's in this course intro Git directory, and then if you unzipped the Git materials in the Git materials directory, and then its subdirectory for commits, and then each of the exercises has its own directory. So yeah, and then you also can find the solutions there if you really need, but I suggest that you try to do them on your own. So I will show you where those are, just in case. So it was course material, Git materials. I thought I had unzipped it already. Let's see. Oh yeah. I unzipped it in a different location. So oh. So Git materials, and then actually the solutions were somewhere else. So they are just under course materials, exercises, solutions. But again, don't check those unless you're really stuck, and I will be around, and also some of my colleagues are going to be around, and we can guide you through the exercise. Okay, but then let's start with the break until 15 past, and then we are going to have, let's see, we are going to have 45 minutes then